Alright, here's one of your quiz question. The first thing it wants us to find is the axis of symmetry and the vertex. Well, since this is in the vertex form, if you didn't notice, in vertex form this is y equals to a x minus h square root, or square, plus k. Now, we know that in vertex form your h and your k is basically your vertex, and in this case it's showing you take the opposite, which is 1 and negative 4. Okay. Now remember, the only reason why I can take the opposite is because it's already in vertex form. Alright? So now I got 1, negative 4. Your axis of symmetry, well, you know that the vertex always lies on the axis of symmetry. So since the x-coordinates is already 1, we know the axis of symmetry must be 1 as well. Okay? Let's come over here and find our vertex, 1, negative 4. And we know the axis of symmetry is where the vertex lies. After we get our vertex and axis of symmetry, we need to also find our y-intercept. And once again, to find your y-intercept is always on the y-axis. So that means your x-coordinates is always going to be 0. So you need just to let x equal to 0 and solve for y. And what that means is if you go back to your original equation, you have y equals to 2. Now your x is 0, 0 minus 1. Okay? Let's solve for that. Solve for the parentheses first. 0 minus 1 is negative 1. Then you would want to square it. So when you square this, it's negative 1 times negative 1, which gives you 1. Put down your 2. Don't forget to bring down your 4. This will give you 2 times 1, which is 2, minus 4, which is negative 2. So your y coordinate is negative 2. You want to put that up there. Complete it. So now you have 0, negative 2, which is down here. Okay, ignore this point. Now we got 0, negative 2. Since this is where the axis of symmetry is, and this is where your vertex is, let's put a little v for vertex. We know that this point has to be equidistant to the point on this side from the axis of symmetry. So since this is 0, negative 2, we should have another point which is also 1 unit away, but 2 units down, so there should be a point right here. So now they're equidistant from the axis of symmetry. And now I can complete my graph by drawing my U shape. Okay. Try to make it as symmetrical as possible. And then the last part of this problem is you need to find your domain and range. Alright. Now recall that the domain, you're really looking at your x-axis. We're going to write it like this. And so your range, you also want to do it, but it's on your y-axis, right? So for your domain, since it's on the x-axis, we're going to come over here, look at your x, and we're going to see how far it's going to move. And it looks like if I extend this number right here, looks like it's about to stop at negative 1, but nope, there's an arrow pointing this way, so it's going to go on forever towards negative infinity. And it looks like if we come over here, it looks like it stops at negative 3, but then the arrow is pointing away, so it's going to continue going, so it's going to be a positive infinity. Now we want to look at our range. Our range is how high and low it can go. Looks like if we go on our y-axis, extend our negative 4, looks like it's going to go and stop at negative 4, so it's going to start at negative 4, and it's going to reach as high as, let's go ahead and extend our 3, but the arrow says that it's going to shoot through it, so this is positive infinity, So we know that the range is from -4 to +infinity. Alright, that's it.